Now we turn our attention to series. We can tell that this is a series because we have plus signs between terms rather than commas. We're being asked to add the first 1,000 natural numbers in this problem. Now let's begin by looking at this very carefully. If you look at the sum of 1 and 1,000, you have 1,001. If you have 2 and 999 added together, you also have 1,001. The same is true of 3 and 998. So we can look at it in the following ways. The sum of the first 1,000 terms is equal to the number of pairs multiplied by the total from each pair. So in this case, we have 500 pairs. There are 1,000 numbers, but dividing that by 2, you have 1,000 or 500 pairs. And the total for each pair is 1,001. Multiplying these two together, we get 500,500 as the sum of the first 1,000 numbers. Now let's generalize this if we could. We want to be able to have a formula for the sum of the first n terms. If there are n terms, then there are n over 2 pairs, and so that n over 2 relates to the number of pairs that we have up above there, and the total for each pair, as we found above, is going to be the first term plus the nth term. So we have another formula here that we wish to add to our list of formulas. Now let's get used to using this sum notation. The subscript after the capital S is how many terms we're going to be adding up. So for this sequence, 2, 5, 8, etc., the sum of the first term is just 2. To find the sum of the first two terms, that would be 2 plus 5, which is 7. The sum of the first three terms would be 2 plus 5 plus 8, which is 15, and the sum of the first four terms, 2 plus 5 plus 8 plus 11, is 26. So let's recap where we're at. When we are dealing with arithmetic sequences and series, we have a formula for the nth term, where you start with your first term and you move forward d n minus 1 times. We also have a formula for the sum of the first n terms, which we just developed up above. Now if you take the first formula, a sub n, and substitute it into the a sub n of the second formula, you then generate this new formula down below. Notice how the s of n and n over 2 just totally match. Instead of a1 plus an, you have a1 plus another a1, making two a1s plus the n minus 1d. Now, you don't technically need this third formula because the first two really are enough, but sometimes you don't have the nth term. You only know what n is, how many terms there are that you need to add up to, and so there's times where this next formula can save you some time. Find the sum of the first 60 terms of this sequence. Okay, well that basically turns into 2 plus 10 plus 18 plus 26 plus ... all the way up to whatever that 60th term is out there. Now what we could do is start with our Sn formula and substitute into this formula. And when you do so, the sum of the first 60 terms is 60 over 2 times 2 plus, we don't have the nth term. So we would have to go off to the side and use the nth term formula, a sub n equals a1 plus n minus 1 times d, to find that. The 60th term will be the starting term 2 plus 60 minus 1 of these 8s that we're adding to go from term to term. This is going to be 2 plus 59 times 8, which is 474. We can now take that 474, move it over to the formula we have at the left here, and that will enable us to find S sub 60. That will be 30 times 476, and that will equal 14,280. Now, alternately, if we didn't want to do that as a two-step process, we could have used the second formula. So let me write this. Alternately, S sub n equals n over 2 times 2a1 plus n minus 1d. That way we can go straight from the beginning to our grand total. This will be 60 over 2, 2 times our first term of 2, plus 59 of those 8s. And if you evaluate that, you will find that we get the same total, 14,280.